Chemical and physical changes. Reflect. Imagine that you took a full sheet of notebook paper and made a paper airplane. What would happen if you cut the notebook paper in half before making the airplane? You would have a smaller piece of paper, but you would still have paper. Now suppose you threw the paper airplane into a fire. What would happen to the paper? How are changes caused by burning different from changes caused by cutting and folding? You need to know what an element is. An element is matter made of a single type of atom. This is kind of like a pure substance. A compound is matter made of two or more types of atoms. Physical and chemical properties can identify substances. Different types of matter, including elements and compounds, have different properties. We can use these properties to identify specific types of matter. For example, when you hear the word lemon, what thoughts come to mind? You might think of the color yellow or a sour taste. These are all properties that describe lemons. Properties of matter are either physical or chemical. A physical property is one that you can observe without changing the matter itself. Some examples of physical properties of matter include color, density, melting, and boiling points. Other physical properties include whether a substance is magnetic or whether a substance conducts electricity. Remember, we've already had a test on these, so this should sound kind of familiar. Right here you can see some of the physical changes. You can cut, chop, bend, sand, melt, freeze, boil, paint, rip, fold, and break. Okay. Now, a chemical property is one that you can observe only when the matter changes as a result of a chemical reaction. An example of a chemical property you can observe is a chemical change such as decaying, burning, flammability, how easily a substance catches on fire, rusting, or cooking. Another chemical property is how a substance reacts when exposed to different chemicals. For example, if you add lemon juice to a glass of milk, the milk curdles or forms large chunks. I'm sure you've seen chunky milk before, and it's pretty gross. Curdling results from a chemical reaction between lemon juice and milk that changes each substance. Right here are some chemical changes: rusting, burning, bubbling, precipitating, reacting, exploding, cooking, digestion, smelling, rotting food. Right here at this picture, it says a substance can be identified from both its physical and chemical properties. Think about what properties help you identify a lemon beside the sour taste and the yellow color. Page 2 of Chemical and Physical Changes. Let's reflect. The picture on the left shows flowers. The picture on the right shows a fireworks display. What physical and chemical properties can you observe about each picture? Well, in the flower picture, you can see the different colors. We could measure to see how tall they are. We could look at the leaves. We can also see colors and probably kind of take a measure of how big and wide they are. However, I bet there are different chemical properties going on. Let's talk about matter. Matter can change. Matter can undergo two types of changes, a physical and a chemical change. Physical changes only involve changes to a substance's physical properties only. Some common physical changes are freezing, melting, evaporating, and dissolving. Think about that with states of matter. With water, solids are ice, liquid is the water, and gas is the evaporation. Sometimes we kind of think of that as steam. Making a paper airplane by folding the paper is a physical change. This paper does not, The paper does not undergo a chemical reaction. Its chemical properties do not change. Like with the paper airplane, You can undo the physical change fairly easy. To turn the paper airplane back into a sheet of paper, simply unfold the paper. To turn ice cube back into liquid water, simply melt the ice cube. Right here it says liquid water freezing to form ice cubes is a physical change. Ice cubes melting to form liquid water is also a physical change. Chemical changes are going to be different. Chemical changes involve changes to the physical and chemical properties of a substance. During a chemical change, a new substance forms. Burning a piece of notebook paper changes the paper's physical and chemical properties. Initially, notebook paper is white. You can crumple it and rip it, but it maintains its original color and composition, or what it's made of. When the paper burns, however, it changes to black, flaky ashes. The ashes are a new type of substance that does not resemble the notebook paper. Unlike physical changes, a chemical change cannot be reversed. You can't unburn ashes to get the original paper back. Here in this picture, you can see burning wood as a chemical change. Like burned paper, the wood changes to ash. Here are some evidences of chemical changes. You can have a color change, like leaves right now outside are turning the orange and yellow and red. Lighting a sparkler for the 4th of July or New Year's Eve creates a chemical change because it's letting off light. Gas bubbles can sometimes form, giving off heat or a temperature change, or forming a precipitate, which means forming kind of a powder. So here's some more. Page 3, chemical and physical changes. Let's reflect. Everyday life. Rust is an example of a chemical change. I'm sure you've seen rust before. If when you're walking down to the bus loop for PE or for Healthy Hero time, sometimes you can notice on the handrails there's some rust. Look closely next time you go. When a piece of iron or steel is exposed to water and oxygen over a long period of time, a chemical change occurs. You may be familiar with the product in this chemical change, rust. Objects made of iron such as chains, automobiles, and bicycles have certain physical properties in common. When a shiny iron object rusts, the object's property changes. Rust is a flaky red substance that crumbles easily. You cannot change rust back to iron. There are ways to prevent rust. In many places when it snows, people put salt on the roads to keep ice from forming. Cars driving on salt-covered roads are more likely to rust. Washing salt off cars helps to slow this chemical change. In addition, people use special chemicals to coat boats and other metals that are exposed to salt water. This would be in the ocean. Painting an object made of iron or steel can also provide a barrier to water and oxygen in the air. The most common place for rust to form on an automobile is where the paint has chipped off the surface. In these pictures here, you can see the nails above are brand new. The bottom here, these have been exposed to the elements, which are usually the water and the oxygen. These have rusted. We can identify evidence of chemical changes. There are several indicators or signs that provide evidence of a chemical change. The only way to know for sure that a chemical change has occurred is to determine if a new substance with new properties has formed. The first evidence is production of a gas. When a gas is produced in a reaction involving a liquid, bubbles form. If you mix two common household items, baking soda and vinegar, a chemical change occurs. During the process, the bubbles that you see are molecules, remember, atoms that are mixed together, of carbon dioxide gas being produced. Carbon dioxide is not present initially. It forms due to chemical changes in baking soda and vinegar. Here you can see that right here. Maybe we'll do this in class. Change in temperature. Chemical changes can either give off heat or absorb heat. Absorb means to take in. When a log burns, a large amount of heat is given off. You feel this warmth if you are near the flames. This temperature change is evidence of a chemical change. Other chemical changes absorb heat. For example, some ice packs contain chemicals that become colder when they react. When you bend the pack, you cause the chemicals to contact each other and react. As a result, the pack becomes cold like ice. These right here are them things you can buy at Walmart, and they are instant hot or cold packs. Another one is forming a precipitate. A precipitate is a solid substance that forms and separates from a solution. A precipitate often settles to the bottom of a liquid. Remember, that sinks. When milk and lemon juice combine in a chemical reaction called curdling, and a precipitate forms. This is a chunky solid substance. This precipitate is evidence of a chemical change. Look here. A color change. A sliced apple that is left out on the table turns brown over time. This is because of a chemical reaction that occurs between the apple and the oxygen in the air. The color change from white to brown provides evidence that a chemical reaction has happened. Production of light. When a substance rapidly combines with oxygen, combustion occurs, producing a flame that gives off thermal energy and light. Burning paper or wood produces light. In some chemical reactions, such as agitating the chemicals in a glow stick, a fluorescent light can be produced. Let's look out for this. When two substances are mixed together, the total weight is always equal to the weight of the additional substances. Basically, what this means is, if you had all the contents or the stuff inside your backpack and you weighed it individually and then added all those numbers together, it would weigh the exact same thing as if you just put your whole backpack full of all that stuff on a scale. When you mix your when you mix matter together, the weight never disappears. The matter never disappears. That's called conservation. So here, you will be working on this later. Try it out. You're going to figure out if it's a chemical change or a physical change. And if it is a chemical change, you're going to have to give us the evidence of the chemical change. And that's it. Thank you.